Good morning, friends. Hope you guys are having a great time at this conference. Thank you, Grant, for the intro. So, Commvault is a software company located in Tinton Falls, New Jersey. We are dedicated to the cause of managing data at large enterprises. I've been with Commvault for the past 18 years, started there as a Banyan Wines developer, Novell NetWare, worked on their storage foundation team. And in the last 18 years, we have seen how the storage industry and the software industry has evolved. So today we'll be talking about data management in large enterprises and the challenges that it causes for our customers there, and how the Commvault data platform helps them to get around these problems. So what are these challenges that large enterprises face? We all know data is growing. Data is growing at a much rapid pace than ever before. It is estimated that by the year 2020, we would have about 44 times the data that was there in 2009. And what is interesting is 1/3 of this data probably is in some form of public cloud or the other. Data needs to be stored, and the cost of storage is rapidly decreasing. So one idea would be, let's store everything. But that really doesn't work because the rate at which data is growing is exponential compared to the cost of decreasing storage. So you actually have to now find out your relevant data from your irrelevant data. So how do you do that? So you need a data platform that can help you classify the data and identify relevant data from the irrelevant data. The type of data has changed. So the growth of unstructured data has led to the rise of NoSQL databases like Cassandra, MongoDB. You have Solr being used as tier 1 applications at customer sites. Also, the sources of data has changed. You have data being generated by IoT devices, sensors, home automation system, office automation systems. Even the log files that we as developers write has invaluable information for large enterprises, provided you can manage this data in a very cost-effective manner. Assuming that you have figured out a way to classify your data, you have figured out a way to capture the data from all these various sources, you are still left with the challenge of storing this data. You need to be able to store this data in a platform that is cost-effective, not locked down to any particular vendor. And once you store this data, you now need to secure it. Make sure that only the right set of folks have access to this data. Once you store it, secure it, you need to make it usable to users, because what is the point of storing data if nobody can get to it? Which means that the storage system needs to have good access mechanism, should be easy to integrate with your business apps so that you can do something with this data, you can do analytics on it, monitoring with the data that is in there. And guess what? By the time you have finished classifying it, storing it, securing it, the data has already become irrelevant, because even the relevant data loses its relevancy very quickly. So you need to have some form of retention policy around it to ensure that when it becomes irrelevant, it gets destroyed. So that is summarizing the challenge at large enterprises. So data needs to be managed from the point of creation to its destruction. It needs to be classified, it needs to be stored securely, you need to have good access mechanism, you need to have retention policies, and finally destroyed. And that is exactly where the Commvault data platform comes into play. So who is Commvault? Not sure if any of you have heard of Commvault before. Commvault is a software company located in Tinton Falls, New Jersey. We were a part of AT&T, split off in '96. We are roughly 2,700 plus employees, 610 developers. We have development centers in Tinton Falls, Santa Clara, Bangalore, Hyderabad, Pune, and we are aggressively hiring developers. We manage roughly 7 exabytes of active data at customer site, 72 or 73 exabytes of passive data at large customers. We have been nominated 6 times leader in the Gartner Magic Quadrant for enterprise backups. 100% of our software has been written in-house, organically developed. We have never acquired any software. Our software is completely hardware agnostic. It can run on-premise, in the cloud. And all this while maintaining a 96% customer satisfaction ratio over 20,000 customers. So Commvault in numbers, so 612 billion files. These are numbers that we get only from the customers who will let us collect this data, so we have a lot more than this. 3 trillion blocks of data managed in our deduplication stores, 200K laptops, 1 million servers, 1.5 million virtual servers, 24 billion objects indexed in Solr, and about 7 exabytes of active data. In addition to this, we have 7 cricket teams, 6 soccer teams, and softball teams. So a lot of entertainment and fun that we have at our workplace. So what is the Commvault data platform, and what does it provide to our customers? It provides a way to collect data. So essentially, we are a backup platform. We capture data from various sources. It allows for basic protection. That is the nature of backup. You need to be able to save versions of all the objects that you capture. It provides a secure storage mechanism. It stores it on a storage platform of your choice. Once it's stored and secured, it gives you access mechanism so that you can analyze, monitor, visualize data that is in our platform, and it allows you to purge this data. So that is what the Commvault data platform offers. All this is driven through a policy-based mechanism, so once you define the policy in the software, you don't have to worry about anything. It's all taken care of from that point onwards. So let's get into the detail of this platform. So what does this platform do? This platform captures data from various sources. So over the past 18 years, what we realized is we have been capturing a lot of data from these customers as part of a backup mechanism, and thus we evolved our platform to do more with the data that we have captured. We ended up with a data lake by accident in some form. So everything that we capture is stored on a storage platform of your choice. We can store the data on disk, on cloud, on tape, or even optical platters. It doesn't matter to us where you store the data. Once the data is stored in the platform, everything in our platform is indexed. So we have a smart index on top of it, and we use Solr extensively for indexing the data. In fact, our index is 4-tiered. We have the content ownership, which tells us where did this data come from, who is the user who created this data, which device created this data. The second tier of index is the storage index. It tells us where is this data stored. So one of the key functionality of our platform is once an object is captured and stored in our platform, we can create copies of that data and store it in multiple locations. One copy could be in cloud, one copy in tape, one copy in disk, it doesn't matter. And all of that locations are indexed, so you can get to this data using that index. Next, we have an object index. The object index tells us the basic attributes of the object. For example, if it's files, file name, location, path, modification time, size, etc., so that you can get to these objects using these attributes. And finally, not the least, the content index, which content indexes the content within the object so that you can find the object using the content within the object, like emails, files, etc. Now, on top of this index, what we did differently is we put interfaces. So the most obvious one is REST, S3, so that you could store objects, retrieve objects using these popular interfaces. DICOM, WebDAV for the healthcare space. So on top of the Solr index, we started talking DICOM protocol so they can integrate it with the healthcare applications. So use it, example use case is the PACS archiving if you want to store DICOM images. SQL, OData interface on top of Solr. So we integrated Apache drill on top of Solr, and thus you can integrate the data that we have in our platform with your favorite BI tools that you use in your business. NFS CIFS protocol, so we have an NFS server and a CIFS server running on top of the platform so that you can take all the data that we have stored and access it through your favorite file application, file-based application. Visualization, we have our own visualization platform that allows you to visualize all the data, create fancy dashboards with the data that is in our index. And finally, an IMAP protocol so that you can get to all the email data that we store in our platform on your favorite endpoint client, for example, Outlook, or your IMAP client on your mobile device. So that you can better visualize the capabilities of this platform, we'll be showing you two short demos. The first one is called the Content Store Mail. So what is Content Store Mail? So Content Store Mail is an infinite mailbox for an end user. We capture emails at large enterprises for backup purposes, and as these backups are stored for a long period of time, the end user can potentially access all these emails on his endpoint device. And you can do all the normal operations that you do with your Outlook client on the data that you are reading off of our platform. So exactly how does this work? When an email arrives at an Exchange server, a copy of that email is bounced off to our SMTP server. And this is just one of the mechanisms in which we capture. So we have an SMTP server running on top of our platform. That SMTP server captures the email and does two things with it. One, it indexes it using Solr. And two, it stores away the original email in our data platform on your storage of your choice. Cloud, disk, doesn't matter to us. Now, this central index or a farm of index or Solr indexes that we have has indexed all the emails that are coming to your Exchange server managed by our retention policies. Now, the second phase of this is on the end user's laptop, we have a trimmed down version of Solr. We nicknamed it Baby Solr. So the Baby Solr has got only the bare minimum components required to talk to the mother Solr, pull down the index, and serve out searches locally on the end user's laptop. In addition, it also pulls down HTML previews of the email from the central server and maintains a cache on the end user's laptop. So it's a good replacement for PST on endpoint devices because you can access all your emails locally without having to be connected to the internet. We have one of our larger customer, 40,000 laptops running Solr on it in this format. So let's take a quick look at a demo so that you can understand how this works.
Commvault's revolutionary content store is built atop the venerable Apache Solr engine. One example of the way Commvault leverages the power of the Solr engine and the content store for the benefit of the end user is with email caching. Take this user's mailbox as an example. Here we have a mailbox with 2.5 million emails, the earliest of which dates back over 6 years to 2010, all while occupying only 25 gigabytes of total space. And all of these 2.5 million emails are immediately available for browse and search seamlessly through the Outlook interface. The user can instantly seek to any point in time from beginning to end. Even searches benefit from the speed and efficiency of the content store. Searching for a common term yields over 1 million results, and here too, the user can instantly scroll to any point in time within those results and interact with their messages. This is the Commvault Content Store, powered by Solr. Emails forever on your endpoint devices.
So the Commvault Content Store Mail allows you to make Outlook work better. It scales it out further. You can access all your emails on your endpoint device via the Outlook provider that we have built on top of the Solr cache. The next example that we'll talk about is Edge Drive. Edge Drive is a file collaboration system that we built for on-premise collaboration. It is similar to Dropbox or Google Drive, except that this can be hosted on-premise, and the data can be stored securely on your storage device of your choice. In this example, we covered this. So in this example, we use the Solr index as a file system index. So we built out a complete file system index in Solr. This index supports all the file system operation: create, read, update, and delete. And the user can access all the data that is stored via this index through your native interfaces like mobile, endpoint devices, browser. In fact, we have integrated a callback file system on top of the index. We use Fuse on Linux to expose this data natively on your operating system, and on Windows, we have integrated with a callback file system so that it appears as a drive letter. All this data that is managed through this interface is stored in our platform, and the Solr index is used as a file system index in this use case. Again, let's take a look at a demo.
The Commvault Edge Drive feature with virtually unlimited storage provides users self-service access to their protected data through mobile apps, including iOS, Android, Microsoft, and BlackBerry devices, a web-based console, and a Windows Explorer plugin. Data resides in the Content Store, a virtual repository for all Commvault software managed data that is powered by Solr, which in turn drives efficiency and enhances value from protected content through access, security, governance, and analytics. When the user is logged into their Edge Drive, they are presented with an intuitive view of their data repository. From this interface, users can perform a variety of management actions, some of which include previewing their data, editing their data, invite other users to share and collaborate with their data, get a public-facing link to externally share data, and tagging files. Edge Drive, unlimited storage in your private cloud.
Both these examples illustrates how the Commvault data platform uses Solr to activate the data that it stores in the storage system that we have. All the data that we store is encrypted, compressed, deduplicated, so that it is stored in the most storage optimized manner. And using Solr, we are able to expose this data for the end users and for the customers to interact with it. The next thing that we are working on with the Lucidworks team is to enhance our platform with machine learning capabilities and NLP. And like I said before, we are actively looking to hire. If you have any further questions, feel free to stop by our booth to talk to us, or you can write to us at our email address. Thank you, and you guys have a good rest of the day. Bye-bye.